So, finishing off with normal distribution, one thing we forgot to check is, I want to know what is the probability that a z-score would be less than 4.3. Z-score is less than negative 4.3. Probability that z-score is more than 4.3, and the probability that z-score is more than negative 4.3. Now, if you look at your z-score chart, the z-score chart actually finishes at negative 3, and it only goes up to, it's a little dark, isn't it? And it goes up to positive 3. So it goes up to positive 3 over there. So, what we do is, if we took a look at the, so our normal distribution curve, it does go to infinity, but our chart only goes from negative 3 to positive 3. Now, so my first question is, if you have a z-score of 4.3, what is the probability of being less than 4.3? And so the probability of being less than 4.3, effectively, roughly 100% of the probability is between minus 3 and 3. I think it's actually 99.7. So it's actually 99.7 is over there. But to all intents and purposes, it's between minus 3 and 3 is 100%. So the probability of being less than 4.3 is 100%. Now, conversely, this is minus 4.3 is to the left of it. And what's the probability of it being less than that? And, well, the probability of that, of course, is going to be 0%. And the probability of being more than 4.3, so this or higher, that's nothing. And the probability of being this or higher is 100%. Okay. Next, in between probabilities. So let's say, for example, so normally what I usually do is I do a multiple choice, but in the interest of brevity, I'm just going to show how we do it. So let's say, for example, I know that 17% of the, there's a 17% probability of being less than A, and there's a 37% chance of probability of being less than B. And so my question is, what is the probability of being between here and here? So if that's 17 and that whole thing is 37, then the probability of being between here and here is, of course, going to be 20%. Or to put it another way, the probability that our x is between A and B is going to be the probability that it's less than B minus the probability that it's less than A. So probability it's less than the bigger one minus the probability that it's less than the smaller one. Okay. So let's do some actual examples now. That'd be the way to go, I think. So recall, just in case you've forgotten it by now, that the formula for z-score is x minus mu over sigma, which may come up. Okay. So the mean length of time that a pandemic lasts is 220 days with a standard deviation of 11 days. This is, of course, not true at all. It's completely made up. That's it. How long have we been doing this? April, May, June, 90. If it's true, we've got another couple of months left to go. So, what I'm looking for here is, oh, I didn't actually ask the question. So the question is going to be, what is the probability that the pandemic will last less than 215 days? So, given that this is true, given that the blue is true, the question is, what's the probability that the pandemic will last less than 215 days? So what we are asking for here is, I want the probability that x, which is the length of the pandemic, is less than 215. And it's continuous, because time is continuous. It could be any amount of days. So, what we're going to do is we need to, we can't look that up on the z-score chart. We've got to turn that into a z-score. And so we know that the mu is 220. The standard deviation is 11. So the z-score is going to be the x value minus the mu value divided by 11, which is going to be 215 minus 220. I don't know why I put that in a calculator. It's clearly -5. Divided by 11. So that's equal to minus 0.45. We're going to generally round z-scores to the 100th because that's what the chart gives. So that's our z-score. So this then becomes, that's kind of like an aside. So what we know now is, we know that that's the probability that the z-score is less than negative 0.45. Take a look at the handy dandy chart. Onto the negative side, negative 0.45 looks like 32.64%. So the probability that it lasts less than 215 days is 32.64%. Now let's do a part B. So I have to rewrite the question. So part B is going to be, what is the probability that the pandemic lasts at least 237 days? So that means 237 days or more. So I want the probability here that x is more than 237. So again, I'm going to need my z-score. So the z is going to be the x value minus the mu, which is the 220 from before, divided by 11, which is 17 over 11, which is 1.545, so I'm going to round it to 1.55, which is 1.55. So the z-score is 1.5. Oh, that is totally off the paper. No, we're good. So it's 1.55. And that's kind of our side. So that's the same thing as the z-score being greater than 1.55. Now, as you may or may not recall, the z-score chart only gives you the probability of being less than. So what we have to do is we're gonna have to change it to the opposite. So the probability of it being more than that is 1 minus the probability of it being not less than 1.55. And so if I look up 1.55, that gets me 93, 94. So it's 1 minus 0.9394, which would give us 6.06%. So the probability that the pandemic lasts at least 237 days is that. Now, let's do a C part. I'm going to cheat slightly because, yeah. So what is the probability that the pandemic lasts between, what values did I use? 215 and 237. Between 215 and 237 days. So this is an in-betweener. So what I'm looking for is I want the probability that 215 is less than x, which is less than 237. And the way we do those in-betweeners is this thing over here, where we find the probability of less than for both and then subtract. So this is going to be the probability that x is less than 237 minus the probability that x is less than 215. And from part B, I remember that the probability of it being less than 237 is 0.9394. And the probability of it being less than 215 is 0.3264. So this is shamelessly stolen from part B and part A. 9394 minus 0.3264 is 61.3. And so the answer is going to be 61.3%. And that's the probability of it being between those two values. And that's it.